Hello and welcome to my science tutorials. In today's video, we are going to be looking at how to find the maximum and minimum point of a trigonometric function of the form f of theta is equal to a cos theta plus b sin theta. Before we begin, if you are new to my science tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So, whenever we have a trigonometric function of the form f of x is equal to a cos theta plus b sin theta, and we are to find the maximum or the minimum point of this function, all we need to do is to reduce this function into the form what r sine into brackets theta plus or minus alpha, or r cos theta plus or minus alpha. Now, if you are able to reduce the function a cos theta plus b sin theta into one of these forms, then we can say what the value of r over here, the r we have over here, becomes what our maximum value. And then that maximum value occurs at what? It occurs at what? Sine into bracket theta plus or minus alpha is equal to 1, or cos theta plus or minus alpha is equal to 1. That is for the maximum value. Now, for the minimum value, our minimum value will be equal to what? Negative r. So if we negate the r that we get after expressing the function a cos theta plus b sin theta into the form this, if we negate the value of the r, we get the minimum value, and then it occurs at what? Sine into bracket theta plus or minus alpha is equal to negative 1, or if it is in this form, then we have what? Cos theta plus or minus alpha is equal to what? Negative 1. So the only difference between the maximum and then the minimum value is that the maximum value, we take the positive r, okay, the value over here, we take it as r as the maximum value, and then we equate what we have, either sine into bracket theta plus or minus alpha, or cos theta plus or minus alpha, to positive 1 for the maximum value. But then we do the opposite for the minimum value. That is, for the minimum value, we negate the value of the r as the minimum value, and then we equate what we have over here to what? Negative 1 as our minimum value, the point at which it occurs. So with this basic introduction, let's have a look at some practical example. Example number 1. Given that the function f of x is equal to 3 cos x plus 2 sin x, where the value of s is what? Between what? 0 degrees less or equal to x less or equal to 360. We have to find I. What is the maximum value of what? F of x. Then I. For what value of x is the function f of x maximum? Alright, so let's go ahead and see. So we have solution. Okay, so first of all, we write the function f of x, which is equal to what? 3 cos x plus what? 2 sin x. Now we need to express this function in the form, because we have cos starting the equation or the function, we need to express it in the form r cos into bracket s minus alpha. Alright, so now since we are to express it in this form, what we do is we expand what we have over here, because we have multiple angles over here, cos into bracket x minus alpha, so we expand it. So if we expand it, we get what? We get cos, this times this, we get cos s cos alpha, then plus sin x sin alpha. That is the expansion of what? Cos into bracket x minus alpha. This is what we get. Okay, now that we have this, we expand, we use the r to multiply through. So we have what? R cos s cos alpha plus r sin x sin alpha. Okay, so now that we have this, we equate, okay, the coefficients of what? Cos s and sin s. What do we mean by this? We have over here cos s, then we have what? Cos s over here. So the coefficient of cos s in this, let's say this is equation 1 and this is equation 2. If we compare cos s over here, we can see that the coefficient here is 3. So we have what? 3 is equal to, the cos s over here has what? R cos alpha as its coefficient. So we have what? R cos alpha. This is what? Equation 3. Then we compare the coefficient of what? Sin x as well. So sin x over here, over here has 2 over here. So we have 2 is equal to what? R. We have here r sin alpha. Sin alpha. This is what? Equation 4. Alright. So now, from here, we need to find the value of what? R. To do that, we square both equations that we have over here and then we add them. So equation 3, we square it and then we add it to the square of what? Equation 4. If we do that, we get what? 3 squared plus what? 2 squared is equal to r squared cos square alpha plus r square sin square alpha. So we have over here 3 square is 9 plus 2 square is 4. So 9 plus 4 will give us what? 13 is equal to, we have r square common here, so we factor it out. Then we have cos square alpha plus what? Sin square alpha over here. But now, from trigonometry, we know that what? Sin square alpha plus cos square alpha, or any angle, is equal to 1. So it means all that we have in the bracket over here is equal to 1. So we have 13 is equal to what? R squared. So to find the value of r, we just find the root of what? 13. So this is the value of our r. Okay, so let's proceed. Now that we have found the r, we need to find the angle alpha. To find the angle alpha, we need to do what? We need to divide the equation 4 by equation 3. So we divide equation 4 by 3. Why are we doing that? We want to get tan. Okay, so these are trigonometric ratios, so we want to get tan out of them. So we know tan is what? Sine over cos. So we make the one that has the sine, the first equation, to be divided by the second equation. So we have here r sine alpha, which is equal to what? R sine alpha is equal to what? 2. Then we divide it by what? R cos alpha, and then that is equal to what? 3. So it means the r will cancel out, and then sine alpha over what? Cos alpha will now give us what? Tan alpha is equal to what? 2 over 3 is 0.6667. So our alpha is now what? Tan inverse of what? 0.6667. So let me use this space. The value of our alpha is now what? 33.7 degrees. Alright, so now that we have that, let's continue and finish with what the question is asking us to do. Okay, so from here we can say what? The function f of x, which is equal to what? 3 cos s plus 2 sin s, has now been reduced to the form what? F of s is equal to what? Root 13, as we have over here, root 13 cos into bracket s minus what? 33.7 degrees. Remember, we we said this should be what reduced to the form what r cos what s minus alpha, and that is what we've done over here. We found the r to be what 13 and then the alpha to be what 33.7 degrees. So therefore the I aspect of the question, what is the maximum value of what f of x? The maximum value of f of x, okay, is equal to what root 13. Then I, the value at which the maximum value occurs is what, because it is maximum, we equate what cos x minus what 33.7 to what positive 1. So we have over here s minus 33.7 is equal to what cos inverse of what 1. Now the cos inverse of 1 is still 0, so our s is now equal to what 33.7 degrees. So it means the maximum value of what f of s is root 13, and it occurs as at the value s is equal to what 33.7 degrees. All right, let's go ahead and look at another example. Example number 2. Given that 4 sine x minus cos x is equal to r sine into bracket x minus theta, where r is greater than 0, we are to find the values of what r and theta and the value of x at which it occurs. Alright, so let's go ahead and find the solution. Now, luckily for us, we've been told the form in which we are to express the function f of x, which is what r sine into bracket x minus theta. So this even makes it easier for us. So the function that we have is what 4 sine x minus what cos x is equal to r sine into bracket x minus theta. All right, so we need to expand this. So we have here r sine into bracket x minus theta. So if we expand this, we have what r, then we have bracket. For sine, we have sine x cos theta minus cos x sine theta as the expansion for what we have over here. Now we use the r to multiply through, so we have here r sine x cos theta minus r cos s sine theta. So this is equal to, so from here we now do what? We compare. From here we compare coefficients of what? Sine x and cos s. So from here we can see that over here sine x is here, so it has 4 over here, so we have 4 is equal to sine x over here has the coefficient r cos theta, so we have here r cos theta. This is our equation 1. So for the second one, which is what cos s, we have over here, we have the cos s over here, and then this one, it has what? The coefficient of what? 1. The coefficient of 1 over here, so we have 1 is equal to, then we have here r sine theta. Now don't be confused, over here the coefficient is supposed to be what? -1, and then here will be what? Negative r sine theta because of the negative over here. Okay, but if I bring the negative over here to make it -1 and then negative r, we can see that the negatives will cancel. That's how come I neglected it. So from here we can say we now have 1 is equal to what? R sine theta as our equation 2. All right, so for us to find r, we need to what? Square both equations and add them. So we square equation 1, we square equation 2 like we did in the first example. So we have here 4 squared plus 1 squared is equal to r squared cos squared theta plus r squared sine squared theta. So we have here 4 squared is 16 plus 1 is equal to what? 17. So we have 17 is equal to r squared. We factor r squared out, so we have cos squared theta plus what? Sine squared theta. So we know that what we have over here is equal to 1, one of the identities of trigonometry. So we have what? 17 is equal to what? R squared. So our R is now what? Root 17 as the value of our R. Okay. So now to find the angle theta, we divide what? Equation 1. We divide equation 2 by 1. Okay. So we have equation 2 divided by 1 so that we can get tan. So we have equation 2, which is this, which is 1 is equal to what? R sine theta divided by, here is 4, then here is what? R cos theta. So we have over here, this is tan, this will give us tan theta because the R will cancel out. So we have sine theta over cos theta, which is what? Tan theta is equal to what? 1 over 4. So let me get some small space. So we have here theta is equal to what? Tan inverse of what? 1 over 4. So our value of theta is equal to what? 14 degrees. Okay. So let me get some space and then we continue. Oh, sorry. I erased everything. Anyway, so we had our R to be what? Root 17. And then we have our theta to be equal to what? 14 degrees. So it means we were able to express 4 sine x minus what? Cos x in the form of what? The R over here is now what? Root 17 sine x minus the theta is what? 14 degrees. Alright, so from here we can see our maximum value okay, is equal to what? Root 17. Okay, and then the turning point over here is the point at which what? The maximum value occurs. So that will be what? Our I, which is the turning point of y over here, will not be what? Sine x minus what? 14 degrees is equal to what? Positive 1. Alright, so we have over here what? X minus 14 is equal to what? Sine inverse of what? Positive 1. So we have this is equal to sine inverse of positive 1 is 90 degrees. So we have S is equal to what? 90 degrees plus 14 degrees, and this is equal to what? 104 degrees. So it means our maximum value occurs at what? Root 17. Okay, it's root 17 and it occurs at the angle S is equal to what? 104. Okay, so let's have a look at one final example and then we end this tutorial. Example number 3. We are to express sine x minus 2 cos x in the form r sine into bracket s minus alpha, where alpha is acute and r is positive. Hence or otherwise, I find the maximum and minimum point of y is equal to sine x minus 2 cos x. I solve the equation sine x minus 2 cos x is equal to 1 for the interval 0 degrees less or equal to x less or equal to 3 6 t. Alright, so let's go ahead and write down our solution. So our solution. So we are to express sine x minus 2 cos x in the form r sine x minus alpha. Okay, so first of all, we expand what we have over here. So we have x minus alpha, and then this is equal to r. We have sine x cos alpha minus what? Cos x sine alpha. Then we multiply through with the r. So we have r sine x cos alpha minus what? R cos s sine alpha. So from here we compare coefficients. Coefficients of what we have in the equations over here, that is sine x and then what? Cos x. So for the sine x, we have sine x over here. So sine x, we have here, the coefficient is 1, so we have 1 is equal to the sine x over here is what? R cos alpha. Then the coefficient of what? Cos x over here is -2, so we have -2 is equal to the coefficient of what? Cos x over here is what? -r sine alpha. That is, this is equation 1, and this, because we have negative at both sides, this is equal to what? 2 equals r sine alpha as our equation 2. Okay, so as usual, we need to find the value of r. So we square and add both equations. So equation 1 squared plus equation 2 squared. So we have 1 squared plus 2 squared is equal to r square cos square alpha plus r square sine squared alpha. So we have over here 1 squared plus 2 squared is equal to what? 5. So we have 5 is equal to r squared into bracket cos square alpha plus sine squared alpha. By now, this should be easy for you. So we have here 5 is equal to what? R squared, because what we have in the bracket over here is equal to 1. So our r is now root 5. Okay, so from here, to find our angle alpha, we need to divide what? Equation 2. Sorry. Yes, so we have equation 2 divided by what? Equation 1, so that we can get tan. So we have what? 2 is equal to what? R sine alpha. Then we divide here by 1. We divide here by what? R cos alpha. Okay, so we have 2 is equal to R will cancel. We have sine theta, sine alpha, sorry, divided by cos alpha. This is what? Tan alpha. So we have over here, alpha is equal to what? Tan inverse of what? 2. So our alpha is equal to what? 63.4 degrees. All right, so if this is the case, let's go ahead and finish with the solution. Okay, so from there we can see we have what? We've expressed sine x minus what? 2 cos x in the form r sine what? Alpha, sorry, x minus what? Alpha. So this is equal to what? The r we found was what? Root 5. Then sine x minus what? 63.4. all right, so from here we can see the maximum value. All right, so the maximum value over here is what? Root 5. Okay, and then the minimum value is what? Negative root 5. Okay, so at what value does the maximum value and then the minimum value occur? So for the maximum value, it occurs at what? R sine what? X minus what? 63.4 is equal to positive 1, neglecting the r over here. So we have what? X minus what? 63.4 is equal to what? Sine inverse of what? 1. All right, so we have x minus 63.4 is equal to sine inverse of 1 is what? 90 degrees. So we have x is equal to what? 90 plus 63.4. So the value of x is what? 153.4 degrees. So our minimum occurs at what? The same thing, which is what? Sine x minus what? 63.4, but it should be equated to what? Negative 1. All right, so if we do that, we have sine x minus what? 63.4 is equal to what? Now, which angle, sine of that angle will give us what? Negative 1. So if we look at sine what? 270, we are going to get negative 1. So we can see that what? The sine inverse of negative 1 is what? 270. Now if you punch this into the calculator, that is sine inverse of -1, we are going to get -90. So you add it to what, 360, and then you get the angle in positive. That is what we have over here. So the value of x is now what, 270 plus 63.4, and then the value of x is now what, 333.4 degrees. So it means the maximum value is what, √5, and it occurs at the angle 153.4 degrees. The minimum value is what, -√5, and it occurs at the angle 333.4 degrees. All right, let's solve the II aspect, that is the equation sine x minus 2 cos x is equal to what, 1. All right, so we have sine x minus what, 2 cos x is equal to 1. Now remember we said sine x minus what, 2 cos x, we expressed it in the form √5 sine x minus what, 63.4 degrees. That is after we found the value of r and then alpha. This is what we said it is equal to. Now if they are saying sine x minus 2 cos x from the question is equal to 1, then it implies that what we have over here is also equal to what, 1. That is what, √5 sine x minus what, 63.4 is equal to 1. All right, so if you're on the same page over here, you can divide both sides by what, √5. So we get what, sine x minus what, 63.4 is equal to what, 1 over what, √5. Okay, and so we have here x minus 63.4 is equal to the sine inverse of 1 over √5 will give us the angle 26.6 degrees. So we have here s is equal to 26.6 plus 63.4, and then the value of x will be equal to what, 90 degrees. So this is the value of our x if we solve the equation sine x minus 2 cos x is equal to 1. So thank you so much for watching, and I'll see you in the next video. Bye bye.